everyone, so we are going to learn about absolute value equations. Before we jump into equations, we're going to talk about what absolute value means. So absolute value means that it's the distance a number is away from zero on the number line. So for example, if I'm finding x and number 1, I'm finding the absolute value of -8. Well, -8 is 8 points away from 0 on the number line, so x would be a positive 8. Since we're doing distance can only be positive, so keep that in mind. Absolute value of something will always be positive. For example, number 2, the absolute value of 3. 3 is 3 units away from 0 on the number line. So the absolute value of 3 is also positive. It's a positive 3. And then the absolute value of 27 would be positive 27. And the absolute value of 2 would be 2. All right. Now 5 through 8 are different because this time x is in your absolute value. And the absolute value of x equals 10. So x could be, inside of my absolute value, could be a -10, because the absolute value of -10 is a positive 10. But also x could be just 10, because the absolute value of 10 would also give you a positive 10 and make this equation true. So x could be -10 and 10. Same with number 6. The absolute value of -5 would give you a positive 5, and the absolute value of positive 5 would also give you a positive 5. So x could be -5 or positive 5. Now number 7 is a little different because 0 is a neutral number, so it's not positive or negative. So for this one, the only value that x could be is 0. X cannot be -0 or positive 0, because again, 0 does not have those negative or positive values assigned to it since it's neutral. So that's just your answer right there. And then lastly, the absolute value of something would never be equal to a negative number. So the absolute value of x, nothing can be put in for x to get you out at -2, because the absolute value of something will always be positive. So actually, this would be no solution. X could not be anything. All right, so this was just a little warm-up, and now we're going to get into the real equations. So when we solve absolute value equations, what we need to do is we need to isolate the absolute values first. A couple of things is absolute values are not parentheses. So we should never ever distribute anything into an absolute value. All of the numbers that lie outside of your absolute value, like in number 9, that +7 lies on the outside of the absolute value, we want to move over to the other side first. So I'm going to subtract 7 from both sides. And now I wind up with the absolute value of a 3x plus a 12 is equal to 0. Now when we're going to look back up at number 7, when we have the absolute value of something being equal to 0, we only had one solution in number 7 because 0 is a neutral number. So same thing in number 9, since we have the absolute value of something being equal to 0, we're only going to have one solution because 0 is a neutral number. So how we find that solution is we drop our absolute values, rewrite our equation, and now I solve that equation for x. So I'm going to subtract 12 from both sides. So I have a 3x is equal to a -12. And then now I'm going to divide by 3 on both sides to get x is equal to a -4. That's your only solution. And that's your answer. All right. Number 10, we also have a +7 on the outside of our absolute values. So we first need to isolate our absolute values. I'm going to add 7 to both sides. Sorry, subtract 7 from both sides. And I wind up with the absolute value of a 3x minus a 7 is equal to a negative 5. Now I'm going to bring you back up to number 8 for a moment. When we have the absolute value of something being equal to a negative number, there was no way that the absolute value of something could be a negative number because the absolute value of something is always a positive number. So we wound up with no solution. So if we look back at number 10, we see that the absolute value of something, because now our absolute values are isolated, is equal to a negative number. And so the absolute value of 3x minus 7 will always come out to be a positive number, and a positive number can never equal negative 5. So right away we can just write down no solution. We do not solve. This is our answer. There is no value of x that would make this equation true. All right, and then now looking at number 11, we have the same exact equation except we have a 9 on the other side of the equation. So I'm going to first start off by subtracting 7 from both sides. And I have the absolute value of a 3x minus a 7 is equal to a 2. I'm going to bring you back up to number 6. Notice, when we had the absolute value of something set equal to a positive number, we got 2 different answers. And that's exactly what's going to happen on number 11. So how I find those 2 different answers is I drop my absolute values and rewrite my equation how I normally see it, or how I see it right now. And then I write another equation by dropping my absolute values and setting it equal to a negative 2. The reason why, negative 2. The reason why we can do that is because we could have this side be the absolute value of negative 2, and it would still come out to be a positive 2 solution because the absolute value of negative 2 does equal positive 2. So I want to see when will 3x minus 7 equal negative 2 because that would also work. All right, so solving my green equation, I'm going to add 7 to both sides. And I have a 3x is equal to a 9. And dividing by 3 on both sides, I get x is a value of 3. So x could be 3. Solving my next equation, I add 7 to both sides. I get a 3x is equal to a 5. Dividing by 3 on both sides, x comes out to be a 5/3. So I'm going to write this as 1. X could be a 5/3. X could also be a 3 to make this equation true. We're going to move on to the next page. I'm going to go a little quicker. Number 12, your absolute values are already isolated. Since your isolated absolute values are set equal to a positive number, we're going to find 2 solutions. So I'm going to drop my absolute values and rewrite my equation normally. And then I drop my absolute values and I set this equal to a negative 6. Solving my green equation, adding 2 to both sides, I get x is equal to an 8. Solving my black equation by adding 2 to both sides, I get x is equal to a negative 4. So my 2 answers, x could be equal to negative 4, but could also be equal to 8 to make this equation true. All right, number 13, my absolute values are isolated and it's equal to 0. Since 0 is a neutral number, that means that we're only going to have one solution. So I'm just going to drop my absolute values, rewrite my equation, and solve. Subtracting 1 from both sides, get x could be a value of negative 1 to make this equation true. Looking at number 14, my absolute values are isolated and I have it set equal to a negative number. The absolute value of something can never be equal to a negative number, so right away we do not solve, we just write no solution. There is no value of x that would satisfy this equation and make it true. Alright, number 15, my absolute values are not isolated yet. So I need to isolate them. I'm going to subtract 4 from both sides. And so I get the absolute value of 2x plus 5 is equal to a negative 1. Now my absolute values are isolated, And since the absolute value of something can never be equal to a negative number, then we just jump straight into no solution. Moving on to number 16. Remember, absolute values are not parentheses, so we cannot distribute that 2 in. Instead, to get the absolute values isolated, that 2 is being multiplied by the absolute values, so we want to divide by 2 on both sides. So now, I'm going to have the absolute value of a 4x minus a 1 is equal to 3. Now my absolute values are isolated. Since they are isolated and set equal to a positive number, we will have 2 solutions. To find the first solution, I just drop my absolute values, rewrite my equation normally. To find my second solution, I drop my absolute values and set it equal to a negative 3. Now I'm going to solve both of these equations for x. I'm going to add 1 to both sides in the first one, and then I'm going to divide by 4 on both sides to get x is 1. In my second equation, I'm going to add 1 to get a 4x is equal to a negative 2, and I divide by 4 on both sides to get x is equal to a negative 1/2. So my solutions for number 16, x could be a negative 1/2, x could also be a 1 to make this equation true. Okay, in number 17, we have 2 numbers on the outside of my absolute values. I have a 1/4 and I have a +1. It does matter the order that we do this in. The 1/4 is being multiplied by the absolute values, the 1's being added on. We take care of the addition before the multiplication when solving equations. So I'm subtracting 1 from both sides. I should never divide by a fraction, so instead I'm going to multiply by 4 on both sides. And I'm left with the absolute value of 2x minus 6 is equal to a 4. Now my absolute values are isolated. Since my absolute values are set equal to a positive number, then we can create 2 equations and find 2 solutions. In fact, it's required for you to find those 2 solutions. So, I wind up with these 2 equations. I'm going to have you pause the video and solve those both. Alright, x is equal to 1 and 5. I'm going to have you pause the video and do 18 and 19 completely on your own to see if you can do these. Alright, and number 18, since your absolute values are set equal to a negative number, we get no solution. In 19, since your absolute values are set equal to 0, you only get 1 solution, and that solution is 7. Now we're going to move on to a little more challenging ones. So number 20, my absolute values are isolated. Oh, we probably could have done this one. Since my absolute values are set equal to a negative number, we jump straight into the conclusion of no solution. Alright, now we're going to get into more challenging ones. So, number 21, actually, since both sides, my absolute values are isolated, we're going to jump into just dropping my my absolute values, and rewriting my equation. And then I'm going to do the same thing, drop my absolute values on the left. Rewrite my absolute values on the right, make it a negative 2x plus a 1. I need to change the operation in both of those. And now I'm going to solve both of these equations for x. So in my first one, I get x is equal to 6. In my second one, that should be plus 2x. I get x is equal to a negative 4/3. But that's how we would do these types of problems. So now I'm going to have you pause the video just to make sure that you know how to do these problems. And a careful reminder, it's always a good idea to check your answer after solving an equation. Pause the video, try the next one. Number 23 is tricky. One of your equations comes out to just